we are going to split this problem into three parts. So I'm going to call this as part 1, and this as part 2, and this as part 3. Okay, and we will first find out what are the forces which are acting on each of these parts, and then we can find out what is the deformation. Let's start with part 1. So in part 1 I have a configuration like this with a 130 shown this way. So if part 1 has to be in equilibrium, this must also be 130. So part 1 is under tension. Okay, now let's go to part 2. Now if you look at part 2, a load of 200 kilonewton is shown. Right now there is 130 is already taken up by part 1. So part 2 will be subjected to a compressive load of 70 kilonewton this way. Okay, now we can come to part 3. Okay, when we come to part 3 is here. There is a load of 330 kilonewton acting to the right. To the right I have already taken up 70, so the rest will be 260 kilonewton. Okay, so we have the loads on all of them. What we have to do is just now we know it's two of them are subject to tensile, one is compressive, so just we'll give a negative sign to the compressive load and then find out what is the total final change in length by using the formula FL by AE. Now for each of these parts, so we just have to do this. So delta L will become F1 L1 by A1 into E plus F2 L2 A2 into E plus F3 L3 A3 into E. The lengths are given, the Young's modulus is given, the forces are known. Only remember F2 is negative because it is compressive. If you do this, your final answer will come down to 1.775 millimeters.